Hello students, this is the lecture for ultrasonics. In this lecture, we will see what is meant by ultrasonic waves. We will go through properties of ultrasonic waves as well as we will go through the production of ultrasonic waves by magnetostriction method and by piezoelectric method. The word ultrasonic comes from Latin roots ultra, where the meaning of ultra is beyond and sonic is sound. The sound waves. Ultrasonic waves are sound waves. Sound waves which have frequency below 20 Hz. Below 20 Hz. These are called as infrasonic waves. The waves which are audible to human being. These are 20 Hz to 20 kilohertz. So these are the frequencies which are audible to human beings. And the frequency, if they are greater than 20 kilohertz, then these are called as ultrasonic waves. So these are the frequencies of sound waves which are beyond audible limit of human being, that is above 20 kilohertz. So these are high frequency sound waves. These ultrasonic waves have wide applications for imaging, detection and navigation. See the properties of ultrasonic waves. The ultrasonic waves have high energy content. They are waves, so they will get reflected, refracted and absorbed like ordinary sound waves. They can be transmitted over large distances with no appreciable loss of energy. So they can travel long distance with no loss of energy. If an arrangement is made to form stationary waves of ultrasonics in a liquid, it serves as a diffraction grating. It is called as an acoustic grating. Ultrasonic waves produce intense heating effect when it is passed through the substance. Ultrasonic waves are produced by magnetostriction oscillator or piezoelectric oscillator. Magnetostriction oscillator is based on magnetostriction effect, whereas piezoelectric oscillator is based on piezoelectric effect. Let us see what is this magnetostriction effect. When a rod of ferromagnetic material like iron, nickel. When such a rod is placed in the magnetic field parallel to its length, let us show this. Is a rod which is placed in the magnetic field. So, see, the rod of ferromagnetic material is placed in the magnetic field parallel to its length, then the rod suffers change in the length. This change is independent of direction of magnetic field. Direction of magnetic field but depends on magnitude of magnetic field. Magnitude of magnetic field. See now, when a rod of ferromagnetic material is placed in the magnetic field parallel to its length, then the rod suffers the change in the length. This change is independent of the direction of magnetic field, but it depends upon the magnitude of the magnetic field. This phenomena is called as magnetostriction effect. Nickel. Nickel exhibits this magnetostriction effect to a great extent as compared to other ferromagnetic materials. This magnetostriction effect can be used to produce ultrasonic waves. Let us see how this is made possible. If in this magnetostriction effect, the rod is placed in alternating magnetic field. The rod is placed in the alternating magnetic field instead of a steady magnetic field. This magnetic field, it is not steady, but it is alternating magnetic field B. We know that the change in the rod, the change in the length of the rod is independent of the direction of magnetic field, but it depends upon the magnitude of the magnetic field. So, see, in the first half cycle, the magnitude of the magnetic field will rise. It will become the maximum value. It will reach the maximum value. So, in this half cycle, if the rod suffers expansion, then after this half cycle, the magnitude goes on decreasing. So, in the first half cycle, if the rod suffers expansion, then in this half cycle, the rod will suffer contraction. Again, in the magnitude goes on increasing in the negative direction here. So, the rod will suffer again expansion, and here it will again suffer contraction. So, if instead of a steady magnetic field, if such a ferromagnetic rod is placed in alternating magnetic field, then the rod will suffer alternate expansion and contraction. In this direction, it will suffer expansion, then in this region, it will suffer contraction. Again expansion and contraction, and so on. Thus, this results in the setting up of vibrations in the rod. What will be the frequency of these vibrations of the rod? It will be twice the frequency of the applied magnetic field. When this frequency of the alternating magnetic field is adjusted to equal to the natural frequency of the rod, then the resonance will take place and this rod will vibrate with maximum amplitude. If this frequency of the alternating magnetic field, if it is in the ultrasonic range, that is greater than 20 kilohertz, then the rod will vibrate with the twice frequency of that applied magnetic field, and as a result, this air at the ends of the rod, will vibrate with the same frequency which is in the ultrasonic range. These vibrations in air at the ends of the rod with a frequency which is in the ultrasonic range. These vibrations in air will produce ultrasonic waves. This is the principle which is used in magnetostriction oscillator. This is the magnetostriction effect what we already have talked about. Now let us see what is this piezoelectric effect. Certain asymmetric crystals like quartz exhibit this effect. Asymmetric crystal means the physical properties vary with the direction. Those are asymmetric crystals. In this effect, when a pair of opposite faces, let us consider this pair of opposite faces, it is subjected to pressure. A pair of opposite faces is subjected to pressure, then equal and opposite electric charges are developed on the pair of faces perpendicular to this pressure. So this is the pressure we have applied in this direction. So along this pair of opposite faces, see that equal and opposite charges are developed. I will repeat. We have applied pressure in this direction to this pair of opposite faces. Then equal and opposite electric charges are developed in a direction perpendicular to this pressure along this pair of opposite faces. If this pressure is replaced with the tension, what is the meaning of this? We are not applying pressure, we are applying tension. Then the polarity of charges gets reversed. There is direct proportion of the pressure or tension applied to the electric charges developed. The meaning is, more pressure we are applying, more electric charges will be developed. There is direct proportion of the mechanical pressure or tension what we are applying and the electric charges which are developed in a perpendicular direction. This is piezoelectric effect. So, what is piezoelectric effect? Tension or pressure applied in one direction results in electric field in a perpendicular direction. Tension or pressure which is applied in one direction results in electric field in a perpendicular direction. So when we apply pressure or tension along one pair of opposite faces, then electric field is developed across the other pair of opposite faces perpendicular to the applied pressure or tension. This is piezoelectric effect. Now, what will be the converse of this effect? If we are applying tension or pressure, we are getting electric field. What will be the converse of the effect? If we are applying electric field, Do we get the change in the dimension in a perpendicular direction? The answer is yes. So we will say that converse is true. Converse of piezoelectric effect is true. So if we place this asymmetric crystal, if we apply this electric field to such a crystal, if we are applying electric field in this direction, say plus and minus, we are applying electric field, then what we should get? What is the converse or inverse of piezoelectric effect? If we apply electric field in one direction, then we should get change in the dimension in this perpendicular to this electric field. So we will get this change in dimension. Change in dimension. So this is converse. This is, what is this? Is converse or inverse of effect of piezoelectric effect. Applied electric field causes change in dimension. Change in dimension in perpendicular direction. So if we are applying electric field in this direction, then we are getting the change in the length. This is converse of the effect, piezoelectric effect, or inverse of piezoelectric effect. So in inverse piezoelectric effect, we are applying electric field in this direction. We will get change in the dimension along this direction, which is a perpendicular. Now, instead of steady electric field, we are applying alternating electric field. So what will happen in the first half cycle? In this first half cycle, say this terminal is positive and this end of the plate is negative. So in this direction, say we are getting compression. But in the next half cycle, what is going to happen? The polarity will change. This negative terminal, this negative plate will become positive, and now this will become negative. So the direction of the applied electric field changes. So in this half cycle, we will get expansion of the in the dimension, right? So if in this half cycle, if we are getting compression, then in this half cycle, we will get expansion. So if instead of steady electric field, if we apply alternating electric field, then the crystal will experience the change in the dimension. In the half cycle, it will experience compression. In the next half cycle, it will experience expansion. So in this way, the crystal will be set into vibration. It will be set in vibration along this direction. Alternate compression and expansion it will suffer. If this frequency of the applied electric field, it is adjusted to such that it is the natural frequency of the crystal, then this crystal will vibrate with the maximum amplitude. The resonance will take place if the frequency of the applied electric field it is adjusted so as it is the natural frequency of the crystal, then the crystal will vibrate with maximum amplitude. And further, if this frequency of the applied electric field is in the range of ultrasonic range, if the applied electric field is of the frequency which is in the range of ultrasonic frequency, then what will happen? The crystal will vibrate with the same frequency as that of the applied electric field. So the crystal will vibrate with the frequency which is equal to the applied electric field, and as a result the air which is at the ends of this plate, air which is at the ends of this plate, piezoelectric plate, it will vibrate with the same frequency. And these vibrations in air with a frequency which is equal to applied electric field which is in ultrasonic range, air will vibrate with a frequency which is in the ultrasonic range, which will produce ultrasonic waves. In this way, inverse piezoelectric effect is used for the production of ultrasonic waves. This is the principle used in piezoelectric oscillator. See the statement of the piezoelectric oscillator what we have already studied. So, if mechanical pressure is applied on the pair of opposite faces, then the electrical charges are developed along the other faces. This is piezoelectric effect. And the converse of the effect is also true. What is the converse? If electric field is applied to one pair of faces, then the change in the dimension in the opposite pair of faces is observed. This is inverse piezoelectric effect. Thank you, students.